Great. Thanks, everybody. Apologies I can't be there in person, but really would like to thank the team from RAF to make sort of all this arrangement possible at the really short notice, and also inviting me to talk about and really introduce the topic around big tech and big data and what it can do for precision livestock. You've probably been hearing, and I have heard some of the talks, and I think I won't go over some of the things that have been mentioned before. But as we know, the challenges in livestock production, whether that has to around global food security, whether that's around net zero, and whether that's sort of the pressure from consumer around high welfare and consumer perception. So the precision livestock farming, in terms of, if I think about it and the term and how long it has existed, it's around nearly 10 years, and it sort of gives this concept of this real-time continuous monitoring of different elements. And so there has been a great sort of advance in technologies and what can we measure, and actually where it's leading as well. I mean, here we have things that we can measure on animals, but again in metagenomics, elements that all link around pathogens, and also gene editing is also knocking on our doors. So the expansion of what we can do and what all these technologies offer is huge. And I think the key question, as previously mentioned as well, how can it be helpful? So I think one thing that has probably really led to a lot of technologies coming on board, and also a lot of techniques in terms of data analytics that are available to us, is around these computational advances, around our ability to really crunch that data and make the kind of space between physical devices and the Internet of Things much more easier in terms of transition. When I think about big data, I'll just sort of say what I mean by big data. And I think it's sort of, the way I see it, sort of lot of structured, unstructured, or semi-structured data that's generated in high speed and volume. And sensors allow us to do that. It could be volume, velocity, and variety. But some of the new things that we are starting to think as the big data and technology has come is around veracity. So, and we are collecting all that information, and actually how reliable it is and how truthful and accurately it represents the reality. And then the other V that's being added as well is around value. And we are starting to think, what value does it create, and which type of data, and to who? And I think these are very important questions that we need to think longer term in terms of applying precision livestock in farms. Once we have the big data, I think about sort of where we are in terms of data analytics maturity, and especially in our field. So the very, very least sort of stage is around descriptive analytics, is around sort of really looking at what happened. And I remember sort of doing my PhD, some long time ago, and very much what I was doing starting was very much descriptive, a very snapshot, and basically what happened, and then trying to relate to things that were collected previously, some sort of risk factors. But essentially, it was very much around some analytics, but mainly of the snapshot. But what the precision livestock or precision technologies help us to do is enter into more further down the line around diagnostic analytics. So why did it happen? And that is because we have multiple repeated measures, and we can start to classify things. But equally, then we can start thinking, okay, we have classified whether it is a disease, whether it is a state of behavior. After we have done that, we are thinking about actually what will happen, and predictive analytics. And there are questions for some applications in veterinary, we are there, but for most we aren't there. We are around diagnostic analytics. But essentially, what we want to do, and what the aim is, that when you have this data and big tech, you can go on to what we call as prescriptive analytics, and how can I make it happen, and how those processes can be automated. So for example, we have a a system where we sort of predict cows or sheep from becoming lame, or we have any other disease, then the question is what options are there and how those could be automated as well. And that's the route that we can take. So what I'm going to do now is sort of frame this thing in three ways. So first, I'm going to talk about examples of our research and think about the challenges that we have and how we went about solving that. Then going to talk about adoption of technology, some of the work we did around farmer perception, adoption, what do farmers think? And then maybe frame towards the end, which would, I think, nicely lead into the discussion around wider societal and ethical implications of big tech and big data. So the first sort of, when I got into it, sort of really thinking, I did my PhD on lameness. And one of the things was, okay, how could we develop something that can automatically detect lameness? Doing the PhD, I could see the sheep nodding their head and say, okay, with some sort of technology, that's possible. So we linked up with industry, with Intel, and started to think about, how could we actually transform big data into smart data, and how could we solve this problem? So we started with a sensor, and the issues that we have to consider, and these exist still, some of them at least, that how could we have a solution that is suited to extensive environment, about battery life and weight, where should we put the sensor, how often we should sample it. And when we were looking at the literature of already existing science around already existing technology, we didn't find much around kind of the rationale about why a certain sampling rate was chosen. Then the question was, what processing techniques shall we use and how should we transmit the data? And I think this was a very co-development process, working with multiple disciplines. And I thoroughly enjoyed that, and I gave us a lot of insights. So we looked at both ear and a collar sensor, which had an accelerometer and a gyroscope. Most studies worked with accelerometer. We wanted to have the gyroscope. So the difference is accelerometer gives us a linear acceleration, but gyroscope helped us to look at the angular velocity. And the rationale was, if we want to have the sheep nodding, gyroscope features might be quite useful. So we utilized that. We built the kind of the sensor. And actually, original hypothesis was that actually, if we could classify animals standing, walking, lying, and when we pick their walking, then we will be able to see the nod and classify lame and non-lame. But eventually, actually, what was very interesting, and that's kind of the strength of when you're getting sensor data and signals, what we found that the lame sheep behaved differently in each of the aspects. So even from standing and lying, there were signatures that helped us identify whether they were lame or not lame. And actually, this was very useful because walking, if we look at it, it's a very 3% of the total time you would, or 10% around, that you would see a sheep walking. So it was great that we could able to identify lameness in all these behaviors. Then the question is, okay, we have classified, we have used data on a farm or few farms, but what about the challenge that sometimes we try and use on different farms that actually the sensors don't work in the sense we don't get the same sensitivity, specificity, or predictive values. So we started off thinking about how can we tackle that. And we used that by two ways. We wanted to use something called edge computing, which is basically an idea where you analyze the data very near to the device. So this is basically just a way of simplified mechanism that we used our algorithm, but we also used the data on the current farm and updated our predictions. And that helped us to achieve accuracy better than if we would have used our original algorithm, because on a new environment, you have different factors that could affect your accuracy. Then we solved the question of, okay, we can have few behaviors classified by a sensor, but what about we want to classify multiple behaviors via a single sensor? And the reason why that's important is For example, we want to see, for example, in this video, you see sort of calves with sort of play behavior, and we want to also classify these because these could be indicators of positive welfare. So we did the study, and what we did, we looked at different sampling rates, and we used a machine learning algorithm to then classify all these different behaviors. We managed to reach higher accuracy, sensitivity and specificity, recall and precision, if you like, and for most of the behaviors, but there were certain that were different. We also tackled another challenge, and that challenge was that when we have classifiers, we look at quantifying them. So we don't only want to know whether the animal is playing, we want to know the percentage of that behavior. And the problem is that generally with a lower prevalence, when you don't have a behavior very commonly happening or a disease commonly happening, it really leads to different estimate, over or underestimation. So by using another technique, we were able to really look at, so these on the graph, what you see is the incidence of play behavior, and one is the actual and one is predicted. So in our case, we were able to have only a very small overestimation compared to published work where the overestimation was around 200%. Okay, the work we are doing in lameness as well, we are looking at the more advanced techniques such as deep learning, gait analysis. And on the left-hand side, you can see that actually the red is the normal gait, and with the lame one, that's the blue one. So there are certain signatures in the gait which you can also identify. And on the right-hand side, what it tells you how smooth the gait is, so how harmonic the gait is. And these are very interesting features that help you to then classify lameness in cows, and we were able to achieve good accuracies. Okay, I talked about big data at the start, but actually we managed to have a project where it's funded by CRV, where we have around 2,000 herd and many cows, and have data from production, reproduction, behavior. And what we are trying to do is use that for prediction. However, there are challenges in heterogeneity of data on different farms. So we are working at what methods we can use to utilize this data and produce different algorithms. I want to finish the current work on kind of really saying where we are heading next. So we can use the sensor data for predicting health and welfare, but what about defining and predicting resilience? And here we are using multi-sensor data fusion. So this is the work, and you can see these are all the calves, and we are able to monitor where they are, their location, and we are using this to really look at space use. We are looking at social networks, and this is on the right-hand side. Basically, you see a trajectory of the calf. So of course, this calf seemed to be really moving around a lot on this particular day. So you can really start to draw some heat maps of the area utilized and use that in some kind of phenotypic marker. In same way, I'm trying to look at that. We are also looking at utilizing thermal cameras to really look at the temperature and physiology. On the right-hand side, we can see the bolus data. On the left-hand side, we can see the eye temperature when they are feeding. I just want to play this a little bit where we are, if I can. I'll leave. So that was basically just saying the video, how we can detect eyes. Now, final few thoughts on technology on farms and leading to our debate in the sense. So I think while we have all this technology, we need to think about what drives adoption. And this is some of the work we have done on sheep farms, and where we surveyed a lot of farmers, and we basically classified them as adopters or non-adopters. And we looked at what factors drive adoption. it's no surprise that farmers who feel the technology is easy to use, it's practical, are convinced of the benefits of the technology are more likely to adopt. Also, IT knowledge, how they use smartphones, that's also a positive indicator. But what was very interesting is that farmers who feel external pressure, pressure from other power sources, if you like, or distrust, general distrust in technologies, and have negative feelings, are less likely to adopt. So these does give us indications how we want to see that. The other thing, that when we interviewed the farmers, it suggested that they have two conflicting frames of reference regarding technology. The first one is that it could be of value to their overall business, but also they thought that it posed risks to their role or identity as good stockmen by creating a physical distance between the two. So I think these two conflicting frames are really creating a barrier in adoption, how they see their role as a good stockman and how they think it can add value. And I think finally it needs to sort of think about how it fits with their current working. So we need to think of habits. And the way to do that is what we are doing, is creating what we call is a living lab, where different stakeholders can come and we can co-create. My final kind of thoughts to say is that, what do we think about the societal ethical challenges of technology and data? I think the first one I would really like to say is around data ownership, accessibility, sharing, and control. So we have farmers that are collecting the data, owns the data, but then we have these other parties where we create algorithms and hold the kind of data in a more interpretable form. And these could be vets as well. These could be other technological companies. So actually, we are not very clear. And I think as we go through the supply chain, the data creates value for everybody. And I think this is something that we need to think about, that how do we share, who do we share with? And it creates opportunity to share data with consumers and get them more involved in food production as well. The second point I want to make is around power redistribution. Because data creates value, it has influence on who holds the power and how power could be redistributed. So the arguments in social science literature is around that it could create digital divide. If we look globally, it could create inequalities related to technology and the way we farm. Equally, it could also create different power balances because of affordability. So who can afford the technology, or where the technology can work better, it might create value there. But what about other where it can't? So how do we deal with that? The final point is about thinking about the hard and the soft impacts on humans and society. So by that I mean is around, it has a great potential in terms of economics, creating economic value, jobs, really changing the infrastructure around ICT in agriculture. I think it also has an impact in how we interpret sustainability and making that very, very visible to all parties. And I think that's a quantifiable thing. And we think about net zero. The softer impacts, and some of them I touched before, are around, what about this human-animal interaction? How would it impact that? How would it change the role of different parties? So there are concerns, and it could add value in terms of, as I said, creating, closing the gap between the consumer and where the food is produced. But I think we also need to think that when we have these technologies, how would it create other changes in behavior? And that could be of consumers, but that could be of farmers, and that vets. So I'll kind of, on that, I just want to acknowledge sort of a lot of the team, actually, the Ruminant Population Health Group and the group I work with, especially the PhD students and the other postdoc and researchers that I presented the work on their behalf as well. So really thanks to them and all the industry partners that we've been working on. And finally, yeah, this is our group. So thanks very much. I'm happy to. I probably overran, but happy to take questions later or gather your thoughts. So over to you, Jonathan.